Welcome to the topic Core Animation Framework. The Core Animation Framework is, is a part of iOS architecture. The Core Animation Framework is a part of view rendering process. So all views in iOS uses core animation by default. So core animation is a part of view rendering process, and so all views in iOS is a the uses core animation. So whether we use it or not, and by default all views uses core animation framework. The core animation framework sits beneath the UIKit framework in app architecture, and it integrated tightly into view workflows of Coca and Coca Touch. So core animation framework sits beneath UIKit framework, and it is interface between a graphic hardware and UI kit. So core animation framework set of interfaces exposed to UI kit framework, and using those interfaces we define the capabilities of views. Animation process is done by the graphic hardware, and we can have a fine grained control over those layers of graphic animation process. So using those fine grained control layers which is exposed by core animation framework to UIKit framework, and so using those fine grained control layers of graphic hardware animation process, so we can define effective animations in our applications. So this is the architecture of iOS application, and in this iOS architecture, core animation sits beneath the UIKit framework or AppKit framework. So core animation is interface between the UI framework and graphic hardware framework, and core animation provides the infrastructure to participate in view rendering process. So core animation framework expose certain interfaces to UIKit framework, and using those interfaces and thus properties of the view can be changed, and core animation is communicate to graphic hardware, and graphic hardware actually does that change in property of view and animate it by default, or you can explicitly define the animation, and that communicate back to core animation framework, and core animation framework rendering that view on the screen. So core animation is the main interface between the UIKit framework and graphic hardware. So all views uses core animation by default to draw view on the screen. So iOS UIKit framework exposes a set of views, and those views we can use to build our user interface without knowing that the core animation is part of those views, unless we define the custom views and we don't use core animation framework. So the the basic views, it is provided by UIKit framework. By default, it uses the core animation, but we don't need to know that the layers of that core animation. So we can define our user interface without knowing that architecture of core animation. So all views uses core animation by default to draw view on the screen. So backing store is different from one view to another view. So displaying a text on the screen, displaying image on the screen, and displaying the different content on the screen is different from is depends on the view. So the backing store and the software, which is graphic hardware software, and the components of core animation is different from view to view and depends on the view, and the backing store is different. So for the image view, the backing store is bitmap. For the text view, the backing store is defined in different backing store, and that will be used by core animation process in rendering the view onto the screen. And the backing store is used by graphic hardware to actually animates the animates and draw the view on the screen. So core animation expose different set of layers to create a view. So core animation frameworks to get a fine grained control over graphic hardware animation, and the graphic hardware animation actually use the software, and that software layers is exposed to the UIKit framework by core animation framework. So core animation framework has defined some of interfaces to graphic hardware, and which actually communicates to graphic hardware to do the animation, and those interfaces and exposed to UIKit framework when there is a properties of view changed, and core animation framework communicates to graphic hardware, and that define a set of layers and to view and to create a view, and we can make use of that layers, and so that we can get fine grained control over graphic hard animation process. So V is composition of the layer, and which manages and manipulate the content of view. So view is by default associated with a layer, and but we can define a set of layers. We can lay down the set of layers in the view, and the the layer actually manages and manipulate the content of the view. So the layer is responsible for manage and manipulate the content of the view. So the layers actually uh, communicate with the graph. The view modifies the properties of the layer, and layer is communicate those properties. It communicate along with the current state of the view to communicate the graphic hardware, and graphic hardware that view state will change depends on the properties, modified properties provided through core animation. And once the state is changed, and that communicate back to core animation framework, which involves the rendering of the view on the screen. So core animation uses layers as interface between the view and graphic hardware. So view handles touch events, layer manages rendering and layout and animations. So view handles touch events, but layers, so view is associated with the layer, and view actually handles the touch events, but layer cannot handle the touch event. Layer only manages the rendering and layout the views and animations. So layer objects are at the heart of core animation framework. So layer captures video content into bitmap that can be manipulated easily by graphics hardware. So in case of in case of image view, that views content converted in the bitmap, and that will be cached in the memory. That is actually state of the view. When there is a change in the view, and that changes the layer model object. So bitmap state and layer model communicate to graphic hardware. So graphic hardware actually changes the bitmap state and communicate back to core animation. It actually updates the presentation layer values which actually render that view on the screen, and that reflects that those properties of the view it is currently displaying on the screen is reflected in the presentation layer of IO core animation framework. So layer modification triggers the animation to change from old value to new value of the property. So when there is a change in the layer object, it triggers the animation, and that animation carries the state of view and model object to graphic hardware and actually does the animation. So layers of view are organized into hierarchy and to create a parent-child relationships. So every view associated with by default one layer. So we can define a set of layers to appear different color, different shapes, and to on the screen we can make use of set of layers, and those layers are parent child relationship, and those layers we can define constraints, and we can lay down those layers on the view to reflect different colors and different animations on the screen. So thank you. This is a basic overview of that core animation framework. So the basic point here is that the view is composed of a layers. That layer we can modify the properties. When we modify the properties which is related to the graphic hardware and which actually draws the view on the screen, and those properties we modify through layer object. So layer object communicates to the graphic hardware which actually does that change. So we can make use of these layer objects to define our user interface, and the layer objects are different from base are different based on the type of the view. And thank you.